Sometimes in Excel you can do a formula, you can get an answer, but you're not really sure what it's really doing. You just know that it looks about right. So here, this is my first video for financial functions, and what is the future value of my money? Another way of looking at it is you are giving $1,000 to the bank, and we put it as a negative because it's coming out of your pocket. You don't have that money, so for the current time, it's like you're losing $1,000. You'll get it back at the end of 3 years. So there's the different arguments of this future value function I'm going to teach you. But really, to think of it outside of Excel, you're giving away $1,000 for 3 years. At the end of each year, you're going to get 10%, earn 10% on your $1,000. And the other thing is, when you earn that 10%, it isn't like they're just going to hand it back to you. They're going to take that interest you've earned and add it to the original value for the next year. So what really helps, and I had an email from someone saying, well, go back to when you used to write on the screen, and I typically write on the screen when it's to do with formulas, how it works inside. So we give $1,000 to the bank, we multiply that by our interest rate, and let's just leave it at it's 10. This is 10%. So we get $100. That's the interest that we get. And now that $100 doesn't come back to us yet. We add it. We're compounding it. So we're adding it to 1,000. So now it's 1,100. And at the end of the next year, this is how they calculate our interest. Multiply it by 10% again. So we know starting with 1,100 multiplied by 0.1, it's going to be a smaller number because it's 0.1. It's not 1.1. Here we have $110 now. And then once again, we're going to take that amount, add it to this amount here, and that's going to be $1,210 at the start of the third year. We're still multiplying it by 0.1. Our interest rate has not changed. 0.1, that's the same as 10% here. This is our third year. And now this is going to equal $121 of interest. So the final step is to say equals this amount added to this amount. So it's going to be $1,331. And this is what the bank is going to hand back to us at the end of the 3 years. So that's what we have here inside of this formula. Let me just turn this off for a minute, and I'll go in here and you can see FV for future value. You see a bunch of references to cells. Maybe it doesn't make a whole lot of sense. I'm going to, here you see the screen tip, the rate. Let me just actually press FX. Click that. Bring this over here. The rate is in cell F7 right there, the 10%. The N per, that is the interest rate per period. So that is our F8 value. There's 3 payment periods, 3 different years as we can see here. And I'm not adding a payment. I skipped that. I even left a blank in here. We're not including this because we're not going to be giving them more money every year. We just gave them that initial PV, the present value, the lump sum. We just handed over $1,000, and as we're giving it to the bank, we enter it as a minus $1,000 from our pocket. It goes to the bank, and then they just work with it. The last argument as well, we're just going with the default. So if we could type in a 0, but it says if the value representing the timing of payment at the beginning of the period equals a 1, but we're getting paid at the end of the period, at the end of the year, so we can either omit it or type in a 0. So I just type nothing. So we see $1,331. I can click this little symbol here. I've hidden the amounts as well in a formula, but some people prefer to see the math done out row by row, and we end up with $1,331, which is the same as here. So in the next video, I'll describe what happens if we add payments to the future value function.